Welcome to Flip Lesson 7.9 as we look today at adding, subtracting, multiplying fractions, and then also working with the idea of finding reciprocals and what a reciprocal really is. So let's get into this idea right away as we deal first of all with addition. Now addition, as you can remember from all your illustrious math career, you get the whole idea of common denominators. You need common denominators to be able to add fractions together. So for example, if you had 1/2 plus 3/4, well, your mental capacity may be saying, oh, I know how to solve that. Technically, right now, we can't solve this, right? Because 2 and 4 are not common denominators, and so you can't actually solve that problem right now, even if mathematically you know what the answer is going to be in the end. But instead, we need this key idea, those common denominators. And to get those common denominators, we're going to have a problem that looks more like this, right? Now, technically what we did here is we converted this and made it a common denominator. Our focus is not on how to make common denominators right now, though you do have that knowledge of how to do that. But instead, we just want to recognize, okay, if we have common denominators, then when we were to add these together, we would get, right, our denominator stays the same, and then we add our two numbers, 5/4. And then of course we want to simplify by turning it into a mixed number in this case. And so it's going to be 1 and 1/4, right? And we've gone over mixed numbers a little bit. If not, there's your fast review of mixed numbers. Okay? All right, here's a quick sample problem. Work through this one and solve it. Then, as we move on from adding different fractions together, we can also talk about subtracting. Subtracting follows that same principle, common denominators. And so in this problem here, we see, okay, we have common denominators, and we need to subtract. Now, looking at a problem like this, if you can visualize it and see it, you can definitely set this up and solve it. But it's usually easier to turn this into more of a vertical problem so that we can easier understand the different parts that we're reading, because everything's lined up now, right? We got our fractions lined up on this side, and we got our whole numbers lined up on this side. So with this principle in mind, then we say, okay, we have a 9, common denominator. Denominator is going to stay the same, so I'm going to take the 5 and I'm subtract 1. So 5 minus 1 is 4, and then 3 minus, and of course there's nothing here, 0. So we get a final answer of 3 4/9. And so we have that concept of subtracting some ideas. And here's one for your pleasure. Go ahead and solve that one. Now that my last example might seem too simple for you, but at the same time, it's one that catches people off guard quite often. From here, we're going to shift and we're going to start talking about multiplication. Now, multiplication has slightly different rules than addition. All right. Now, this problem happens to have common denominators, right? But you don't need common denominators because when we multiply fractions, we're going to do numerator times the numerator and then the denominator times the denominator. So it's going to be 2 times 3 for an answer of 6, and 4 times 4, which gives us an answer of 16, which we would then want to simplify, right? And I'm going to divide each by 2 and come away with 3/8 for a final answer. So here's a quick one that you can go ahead and solve. But there's another triangle here. So after you solve that one, we can also look at this idea, right? Sometimes fractions are going to come in multiple different forms, and we can work with these ideas to help us to solve these. So you've already solved for 2 times 5 and 3 times, or 2/5 times 3/7 is what I meant to say. But now we add in another fraction. And we could just real quickly go straight across 2 times 3 times 5, which gives us a quick answer of 30. And then 5 times 7 times 6, which is 35 times 6, which gives us a quick answer of 210, right? But it's okay to remember some of the things we've learned already in previous math classes, not necessarily this year, right? But it is okay to start using those tricks, right? Of crossing things out, right? And saying, okay, there's a 5 here, 5, 5. This 6 can be broken down to 2 times 3, right? And so that's going to get rid of this one, that's going to get rid of this one, and this one, and this one. And I'm going to be left with 1/7. Which you would find out that if you had 30 over 210, which is what 35 times 6 is going to give you, you're going to come away with the same answer in the end anyway. All right, so don't be afraid to use those tricks since you've already been taught those things. But if you don't remember those right now, we will review them in later lessons and go ahead and just do all the math, right? 5 times 7 times 6, which would get you 210. And of course, that's 6 plus 5. 2 times 5 is going to get you 30, and then reduce, finding your common factors. From there, we get into what's known as reciprocals. And when it comes to reciprocals, we can talk about reciprocals, we can talk about inverting a fraction, and eventually it leads us to this principle, which is going to be the inverse property of multiplication. But basically what we see, if I want to know the reciprocal of a number, mathematically what we're doing is, or I don't even know if mathematically is the right word, visually, I think that's a better word. Visually what we're doing is we're flipping it, right? This fraction, the reciprocal, is flipped and it becomes this, right? The numerator becomes the denominator and the denominator becomes the numerator, and you get this idea. And what you see here is part of what allows you to understand if they actually are reciprocals, because now I've shown you this giant X to say I'm flipping it, right? But it also, right, we know X means multiplication, and so this fraction times this fraction should equal 1, right? 3 times 4, right? Now we're going across like this. Let me change colors to make it clear. All right, 3 times 4 is 12, because that's how we do fractions, right? Numerator times numerator, denominator times denominator. 4 times 3 is also 12, and that equals 1. Yes! All right, we know that those are reciprocals. And really, we can find this property for any number as long as that number isn't 0. So any number in here can have a fraction, can have a reciprocal. Even fractions have reciprocals, as we have dealt with that idea. But the key idea here is when you multiply them together, they should equal 1. So can you find these fast reciprocals? All right. You probably took this one and said, okay, there's my fraction, flip it, invert it, 1/3. And this one you're like, oh man, too easy. Too easy. And maybe it's not too easy. Maybe you're saying, oh, I don't like this. This isn't my favorite. Well, it's okay, because we're going to work with you, help you out, whatever you need as you go through this entire process. Okay, these are your sample problems then to work through understanding the reciprocal side of this lesson. That's it for lesson 7.9. I'll go back to those samples just in case you haven't gotten to them.